So we've got, I believe we've got the going to have the YouTube link in a sec. Tyler's going to paste that in to the chat if you want to watch it afterwards. But yeah, for the time being, maybe we'll just give people a few seconds to join. Maybe post on the chat. Where are you joining us from? So I'm at home in London as usual, and then we've got Alexi. Where are you, Alexi? Amsterdam?
As usual.
Oh, we need some more exotic places from the guests, and we've got Minneapolis. So Nathan. Who else have we got here today? Let's have a look.
Philadelphia, Kevala. Welcome Greece, welcome Germany. Welcome the United States, Israel, Ann Arbor, Detroit, if I recall correctly. India, nice to see you. Bulgaria.
We've got people everywhere.
Not everywhere still.
Where are we missing? What continent have we not got yet?
Australia.
Oh yeah, we haven't got Australia. It's probably like, what is it, like 1 a.m. there?
But still.
3. Come on. Anyone from Antarctica, says Rafi. We got South America? I don't think we got South America.
Not, but we
not
still
yet.
People are
Still time. All right, shall we get started then? I think we probably got everybody who's joining at the beginning.
Yeah, let's start.
I can see the screen, so that looks like it's working.
So here is ClickHouse release 24.11. It is our November release. We have a lot of new features. We will also have a guest talk today. And I hope we will have like 5 minutes for your questions. There are 9 new features, 15 performance optimizations, and 68 bug fixes. So let's take a look. What do we have? And we will start with something really small and nice. Some nice improvements that we make every month just to make our product a little bit better. And the first one is very easy, very simple and trivial. It is about command line, the command line tool. We have ClickHouse local, ClickHouse client, and you can pass a query as a command line parameter, like minus query and your query. You can also specify a file with queries, like here, minus queries file and your script. You can also pipe this script simply to standard input, like this. You can use a short option for query, just -q. And you can use a short naming for ClickHouse local that is simply ch. And if you have ClickHouse installed, ClickHouse local is also installed and available under both names, ClickHouse local and ch. And you can also just omit the -q argument and invoke it as simply ch select something. And now you can also do the same for the script. So you can specify either a query or a script without any extra parameters. And ClickHouse will automatically disambiguate between these two options. Sounds nice. What else? Here is slightly more difficult to explain. It is about higher order functions for arrays. So in ClickHouse, there are arrays and there are a lot of functions to process these arrays with other functions, like array map, array filter, array min, array max, array first. What else, Mark? Do you remember any more higher order functions?
Oh, I forget which one I've been playing with. No, I've been playing around with the you know, the ones that are like pivot style, median map, but I guess those ones are not higher order. They take in maps. That's no good, is it?
Yeah, we need something that takes this argument that is also a function, a lambda function. Maybe ask our audience, what did not I mention? So we have array map, array filter, array min, max, array first. What else? If you will answer correctly, maybe you will have a chance to get this t-shirt delivered.
Don says array reduce.
Almost. This is almost correct answer because array reduce does not take a lambda argument. It takes a name of aggregate function. But we also have one. Okay, 3 seconds. 1, 2, 3. Any answers?
Nope.
What about array fold, array sum, array sort? We have a lot of these
So
type
many.
of functions. Okay, and the difference between two versions is very subtle. So in previous versions, whatever you pass in this function, the function, an array, the expression will not be considered constant, even if all arguments are constant. In the new version, if the function does not reference external columns, if the array is constant, the result will be also constant. And it makes sense because now you can use these expressions in a context where a constant is required. And it also improves the performance. Let me show it to you just as a motivation. Why did I make this feature? So I will start ClickHouse local. Here it is. In interactive mode. And I will do the following query. Here we have an expression with array map, just multiplying something by 2. Let me actually show you this expression just in case. So every even number and 10 of these numbers. And I will also select from system numbers, and I will do a subscript from this array and just measure performance. Okay, here we have 12 billion rows per second and almost 100 gigabytes per second, 98 gigabytes per second. Not bad. Now let me start the previous version of ClickHouse, maybe compare with 24.8. And the same query will run. Mark, what do you expect? What difference in performance?
So what was it? It was 98. I don't know. 60?
Let's see,
49, 50.
maybe it will be 60. Just give it time to speed up. No, it is like 55 gigabytes per second, but you are very close.
That might be my closest guess so far.
Yeah, so in the new version, it is faster because the expression is constant, and doing a subscript of a constant array is obviously faster. Okay, another feature that will require a demo, and it is a very small modification. A slight usability improvement of the vertical format. So again, let me show it on the example. I will start ClickHouse server in one terminal. Here it is. Here it has started. It has a bunch of test tables. And here I will run ClickHouse client. And let's see what are the improvements. First of all, let me run this query as is. It will show the result in a pretty format, in the form of a table with a lot of columns. But this table overflows the terminal. It is quite large. Even a single value is large. So to make it more convenient, there is a format named vertical. And I write it like this. And there is also a short way to write it from MySQL like this. But I always write it like this. So what is the difference? Did you notice?
Oh, it's the numbers.
Yeah,
That's
exactly. There are
nice.
two small differences. First, every large number has a hint. So now it is clear that we have around 100 million records, around 14 gigabytes of data and 54 gigabytes of uncompressed data. And the second one, you will see it if I will show it very closely. The digit groups are highlighted. So here it is clear that we have 54 billion 300 million 390,000 of records. It is clear because of these highlights under the number. And it is pretty nice.
And this we had on the table view for 2 or 3 versions. So now it's here as well.
Yeah, in the pretty format, it is probably from this summary. In the vertical format, it is since the new version. And this feature is even more interesting. It is about a new modifier for the with fill modifier for order by. So what it is? There is an order by expression in SQL, and there is an extension named with fill. After each element in order by, regardless of if it is ascending or descending, you can also optionally specify this with fill expression. And the purpose of this expression is filling the gaps, the holes in time series. Not necessarily time series, whatever series. Optionally, you can specify where to start, where to finish, which will be the step. And the new one in the new version is a specification of staleness. Let me explain. So how with fill works in general. Let's suppose you have a report. It is ordered by something like by date. And here you have dates. March 17th, March 9th, is March 21st. And some dates are missing, you can see it. You want a report to be continuous, so you just specify with fill or with fill step 1, and it will fill the missing values with zeros. There are plenty of options. You can specify irregular time intervals like every month, every year. It will increment carefully by a month. You can specify custom steps. You can even fill by multiple keys. The new one is this staleness modifier. Maybe it is unclear, but maybe if some of you have used Prometheus, tried to implement something for Prometheus, you know this. So let me show how it works. Let me start ClickHouse local and do some queries. The first query will just calculate exponent. Let's start simple. Here are binary exponents. 1, 2, 4, 8, etc. If I apply with fill, I will have a sequence of numbers without any gaps. Let me also illustrate it like following. Here I will highlight the original values and the values that were missing. And now let's apply the new staleness modifier. Okay, so here we specified staleness 5. And what it does, it gives us at most 5 values in total. So here we have no gaps, and here we have filled just 4 missing values. And then we still skip to the next original value. So it will not fill like hundreds of values, just 5 maximum. A simple feature, but I hope someone will find it useful. Okay, another feature, check grant. With this query, you don't have to try another query like select and receive an exception if you don't have access. Instead, you can just check it, check grant, select on, or check grant, insert, and it will return just 0 or 1 if you have this grant. So first of all, what will happen if I will check it inside ClickHouse local? ClickHouse local has all the permissions. You can do whatever you want. So the result is 1. Now let me show it inside ClickHouse Playground. In ClickHouse Playground, I don't give access to this database, so the result will be 0. But if I will do something like this, the result will be 1. So it is a pretty nice feature if you want to implement some UIs and check grants in non-intrusive way without generating any errors. Yet another feature that will require demonstration because it will be difficult to explain. It is about what happens if a query generates an exception, but you already received partial result. Like you connect to the HTTP server, you request your data in CSV, and you already have millions of records streamed to the client, and suddenly you have exception. How to send this exception to the client? We already sent HTTP 200. Okay. The server already sent this status code. And it is quite annoying because in the previous versions, this exception was just inside the data stream, and it was difficult to disambiguate. And you were happy if you used the JSON format, or some other format that will be either correct or just broken on exception. But what if you used CSV or TSV? And actually, this change is a big deal. It actually makes sense. But first, let me run the previous version of the server to illustrate how it worked before. So I will run ClickHouse 24.8. Okay, it runs. And I will send a query with curl, the query like this. Read the numbers, but throw if the number is greater than 100,000. Okay, here is the result. You see it. And here is the exception. And it's difficult because you have the data and suddenly there is exception. And there is no way to disambiguate. Let me also show it as follows. The program returned 0 exit code, like everything is okay, but it is not okay. Okay, let me compare with the new version. Here it is, here it runs, and the same query, what will be the difference? And now you can see here is the data. Then here is something like this, but it is not what server outputs. It is something that curl prints by itself. And then there is an exception. And also curl argues that there is an error in the chunked transfer encoding data format. So in the new version, whenever an exception happens after the data is sent, we just make the stream invalid. So we make a chance to have HTTP clients, whatever clients, not only curl, also Java client, Python client, whatever client that will read this data will stumble upon this broken format. And the exception will be guaranteed to be propagated. And it is actually a big difference. Okay. What else? Another feature for HTTP interface. If you did not know, ClickHouse allows you to configure custom HTTP handlers. For example, you provide a configuration file, and this configuration file has a handler configured under the report path. And if you request this path, it will run this query, the predefined query. But the query can be parameterized. So you can specify parameters as URL parameters, or you can even extract parameters from parts of the URL or even HTTP headers. What is new in the version 24.11? Now these handlers can impersonate a user. So in this example, this query will run on behalf of a user, Ivan. So it is pretty nice. Okay, a lot of small features, but what do we have for performance improvements? As I promised, in every new ClickHouse version, there is something to improve performance of joins. And you can see that on some synthetic tests, some of these joins improved more than 7 times. But let me again try to motivate it on an example, on a live example. So let me create a few tables. It will be also a synthetic test, but at least we will see it live. So the tables will be named ClickHouse, will be named test1 and test2. And I will insert 10,000 records to the first table. No, not 10,000 records. It will be too small for ClickHouse standards. 10 million records. Okay. And I will insert 1 million records to a second table. It was instant. But don't worry, the data is inserted. And I will join them together. So how quick it will be to join a table with 10 million records to a table with 1 million records. Just inner join, and these tables are merge tree tables. Anyone would like to guess? Mark, your turn.
Amit says 1 second.
1 second.
1 second.
It must be fast. Maybe 1 second, maybe 2 seconds. But let me see. 0.2 seconds. So 267 milliseconds. So Mark, next time, don't say 1 second. Say in the milliseconds range.
Yeah, we don't do seconds.
Because you can even slightly disappoint me by your guesses. Okay, but now let's take a look what it will be for the previous version. And let me find the previous.
Are you running? Amit wants to know: are you running on a cluster or just one machine, one node?
It is just my desktop. It is not a cluster. It is not even a server. It is just a small rusty desktop.
And the data is not partitioned at all, right? You just inserted it into one partition.
Yeah, it is just a merged tree table with a single partition. And partitions, they are often unnecessary. Okay, and let me find the previous version like this. Interesting. Did I lost it?
Your computer doesn't want to run such an old version.
Yeah, it is difficult to locate. Here it is.
Oh, you put in build.
Yeah, let me run ClickHouse version 24.10 and the same queries.
From a whole 26 days ago. Probably a bit longer.
Yeah, almost a month. Interesting how well it
Wait,
will.
so what do we think? This one is going to take... Okay, this one's going to take 1 second.
Okay,
Yeah.
let's take a look. And the previous one
Was 0.25 seconds, roughly. Amit says 0.5 seconds. Amit has faith in 24.10. Anyone else want to guess on YouTube or Zoom? Come on, we need some more guesses, otherwise it's not so much fun.
Yeah, I want more fun.
So I say 1 second. Quinn says 0.87. Amit says 0.5. Have we got anyone who's going to go higher?
Okay, 0.4.
Oh, Marit said 0.5, so he's the closest.
Okay, so you win the
So it's almost 2 times faster on the 24.11.
Yeah, and also one small detail that both queries are using parallel hash join algorithm. If we will remove this specification, it will be, actually, I don't know. Let me check. It is faster. But why it is faster? It surprises me. So all of these optimizations have no use. But nevertheless, why do we have this optimization? Because our aim is to make parallel hash join always faster than the regular hash join. And after we do that, we will just enable it by default. So let me check again. This query is faster, but with parallel hash join, it is not as fast, surprisingly. So 7 times faster was not enough. We demand more optimizations. Okay, another optimization. This is for merges and for select final. So let's suppose you have a replacing merge tree table that does deduplication of your data in the background. During background merges, when you have multiple versions of a record for the same primary key, ClickHouse will keep only the last version. And you can also get this behavior on select. If you specify select something from table final. Final is a modifier. It will do merge on select. And these both operations are optimized in the latest version. It is optimized by checking if the ranges are not intersecting for different parts during query processing. I will not show it to you. Let me show the results from our continuous integration system. So a certain query was optimized 1.7 times. And yet another optimization. It is about the mark cache. So let me remind you. For a merge tree table, there is a primary key, and this primary key contains values every bunch of records, every granular. And for every granular has a mark that points to offsets to read the columns. So these columns can be read from for a subset of data. And the amount of these marks can be quite substantial, so they not necessarily fit in the memory. They are just loaded on demand, they are kept in the cache. What is new in the new version? There is a server configuration mark cache pre-warm ratio. You can set it like to 50% or 95%. By default, it is set 95%. And as long as you have this option, every insertion, merge, or downloading of data part will bring marks for this part in memory, as long as the cache is not, say, 95% full. So subsequent queries will use these marks in memory and not spend time loading them. And also there is a system query, system pre-warm mark cache for a table. It will just load everything right now. And yet another optimization for parallel replicas. With parallel replicas, a query will use resources of every replica in a cluster. That is especially useful if you have shared storage. With shared storage, all your servers are replicas, like replicas without the copy of the data, but replicas that look at the same data and ready to participate in the query processing. And let me show it on a ClickHouse Cloud instance that uses a shared storage. First, I will run a query like this. It is from a table with Wikipedia statistics, and the table contains 528 billion records. Pretty large table. And I will analyze how many different pages and how many page views happened on every pages starting with CLI, like ClickHouse, but anything else. Clicks, ClickHouse, whatever. And this query takes only 300 milliseconds. And parallel replicas are already enabled. If I disable parallel replicas, it will take 700 milliseconds. If I enable 300 milliseconds, no, now it is slower, probably slower because it did not use the cache. Now it uses the cache, and it is just 300 milliseconds. The difference between cold and hot queries. What is new is in the new version. The fact is that this performance is for version 24.11 that has this change, parallel replicas local plan. But if we disable this change and see the behavior of the old version, it will be significantly slower regardless of the cache. 2 seconds. And with this change, I just want to double check it. Don't worry. I'll take some time from this webinar. I need to know if it is really faster. Yeah, it is faster, 300 milliseconds. Yeah, so this makes sense. And the difference is to avoid latency even for short queries. So when your query takes, say, 300 milliseconds, 100 milliseconds, or even 10 milliseconds, you want to use all the resources of parallel replicas, but without any downsides, without any latency increase. You would expect some increase when you have multiple servers participating, but with this new option, it will do the best to avoid any degradation, even for short queries. And long queries will be parallelized, and they will be speed up linearly. Okay, now about something interesting, something big. And one of these features is about workload management. Let's suppose you want to separate queries by different workloads. And you want to separate them by priorities, like 2 times more resources for one user, 2 times less resources for another user. Or you want a strict priorities, like you have only 100 concurrent requests maximum for S3, and as long as a higher priority query using these 100 concurrent requests, low priority query will wait. And it is possible. It is already possible for over a year in ClickHouse with server side configuration with a configuration file. You can configure it like follows. You define resources like a resource name at network read. You classify these resources by this notation, like different hierarchies, and you have a limit on the number of requests in flight, and you have a certain priorities, like everything under this node will be fairly split by different weights, and everything inside this node will be split by strict priorities. Then you define workloads referencing these resources and these hierarchies, and workloads are defined by their names. And in select queries or in a user profile, you just specify a certain workload to use. Like workload is production, and it will get more resources. What is new? In the new version, you can configure everything by SQL queries. Create resource, create workload, create or replace workload, drop resource, drop workload. Here are the new queries. In this example, I define a network write resource referencing writing requests to a disk named S3. I define a few workloads like development and production. And production will have weight 3, and development will have the default weight 1. So 3 times less amount of requests to S3. And I can also define maximum speed in bytes per second for network read. I can also define the maximum number of requests in flight, the maximum burst of requests, the maximum number of bytes in flight, everything. And it works. You can try it today in version 24.11. One more, a new data type. Name it bfloat16. We have float 64, float 32, so double and single precision. And bfloat16 is a half precision float, but quite a special one. It is named bfloat, where B is brain, because this data type is used for AI and vector search. It has just 16 bits. It has 8 bits of exponent, the same number as float 32, and it is useful for low precision calculations, like vector distances, like vector embeddings. For vector embeddings, it will be natural to store them in array bfloat16. And if you do this, the difference in calculations will be not noticeable, but the difference in memory usage will be 2 times, and the difference in performance will be, let me show you. So I have a table with 28 million vectors of 384 dimensions on a single machine with 2 CPU sockets and 96 threads and DDR5 memory. And I do a vector search for nearest neighbors with full scan. So it is a precise vector search without any vector indexes, using this bfloat16 or float 32. And what is interesting, bfloat16 is more than 2 times faster, like 2.5 times faster. And it can even use hardware acceleration with AVX 512, and it does it. So more performance for almost for free. And yet another feature that I want to highlight. It is about data lakes. Actually, if you use ClickHouse, you don't need data lakes. ClickHouse is amazing. It does everything. It does everything nicely. You can share your data between different users. It maintains access control, and it will be faster than any data lake, regardless whether it is Iceberg, Delta Lake, or PuTTY. But in the new version, we support cluster processing of data lakes. So when you specify something like select from Iceberg cluster, It will go to every server on your cluster, whatever number you have, 10 servers, 100 servers, regardless. And it will instruct every server to process your data lake in parallel. So Iceberg will be melted by ClickHouse. Okay, this is about interesting features. And now let's take time for guest talk. And let me introduce Mike from HyperDX. Welcome. You are either muted or I don't hear you.
Oh, apologies. Thank you, Alexei, for the intro. Thanks for the mic check as well. But I'll jump right into it then. Great.
Yep.
So thanks for having me here. As Alexei mentioned, I'm Mike. I'm the co-founder and CEO here at HyperDX. Just quick intro. Prior to this, I was also leading the developer experience team for what was the log analysis product within IBM Cloud. So I probably spent more years of my life thinking about logging and observability than probably someone should. But today, I'm really excited to share more about HyperDX. We're building an open source platform that makes it really easy to search and visualize logs and traces directly on top of ClickHouse. You could think of it as the Kibana for ClickHouse, basically. Here, we're really big fans of ClickHouse as it's extremely performant and it gives us a lot of tools to optimize performance, cost, scale in ways that we really don't get in other databases. So it's no surprise a lot of companies like Uber or Shopify, they're adopting ClickHouse for their observability needs, but often they end up needing to write their own custom UI layer on top to do the actual searching, the charting, so that they could expose like an easy way to use ClickHouse for most of their engineers across the company for observability use cases. And that's kind of the problem we're solving. HyperDX makes it really easy to have like a developer-friendly way to do searching, analysis, dashboarding directly on top of ClickHouse for observability use cases. And a big difference here, of course, is that it's flexible to the data schema that you have. So you can really run HyperDX on top of any table you have in ClickHouse today, and we'll show more of that in a bit. So with that, I'll just dive right into how it works. Let me share my screen. Perfect. So hopefully you guys can see everything. So the first step, and this is kind of like a one-time setup kind of step, is that we'll need to connect to our ClickHouse instance. Here, I'm going to connect to my local ClickHouse instance I'm running on my computer here. So let's just go do that. The first thing I'm going to set up, I'm actually going to set up my traces. So in my local instance, I have a ClickHouse instance, I have an OTel exporter, and I have an application that's just generating logs and traces. So that's kind of a typical, OTel-based setup here. So here we'll, select the OTel traces table. You'll see that it'll look at the table, look at the schema, and it'll do its best to infer basically how to map the columns to the actual, ideas and observabilities like duration, precision, stuff like that. So we'll save that. And then we'll also then create one for logs. So let's just name this logs. Let's go to our logs table. Again, it'll do the same thing. It'll infer, this logs column or logs table, what columns should be associated, and also connected to traces. Because this logs and this traces table, they're connected by trace ID. We'll, let HyperDX know that, and then it'll be able to connect between the two automatically for us as well. So now with all that set up, that's like a one-time setup thing. Now with all that set up, you can come in and you could just hit run, and it'll start doing searches on top of the rows in ClickHouse. So in this case, it's live tailing through the logs table here. So as new logs come in, they're being shown here. One thing you might be interested, of course, is doing some searching. So, we make it really easy to, just be able to do full text search. This is using the Lucene syntax. So it's relatively powerful for most basic searches. So you could do property searches, full text searches, and stuff like that. That just makes it easier for people who, they might not be as familiar with SQL, or they might not need the full expressiveness of SQL all the time for full text. So of course, we could also do the same thing using, SQL, but it just takes, a few more keywords to write out, but of course you can still use SQL as well if you'd like. So all that is fully supported. And then one nice thing is once you find the log that you're interested in, or the row that you're interested in your ClickHouse table, you can always click into it. And we actually pull out the entire, all the columns associated with that row for you on demand. So usually, you have to kind of say like, hey, you're interested in the, service name resource attribute, or, any sort of column here. You actually have to have that in the select ahead of time, and then you get like a big messy list of columns. In this case, you just need, basically the basic columns on the search side. And then when you click into a row, it'll actually select all the columns associated with that specific row. So the other thing, as I mentioned earlier, is we connected the traces to this log. So because of that, we're actually able to, okay, so this one doesn't have a trace, it looks like. Let's see if I can find one that does have a trace. I guess user disconnected doesn't. Hopefully dispatching API call does. Yep, there we go. For the logs that do have traces, you'll be able to see the trace associated with it. So here you'll see all the spans in the traces table. It's being linked by the trace ID. You can then step through and see, every single span associated with that. So you kind of get that unification of your logs and traces in a single panel. You don't have to hop across multiple apps or, basically try to pair two different tables together across different panes. You could kind of see them all in a single place together all at once. Let's see here. What else should I be covering? So the other thing that we do as well is that this works on, right. One last thing before I actually hop to that. One thing that we do as well is, of course, analytics is a really strong part of ClickHouse. Being able to do aggregations is a really strong part of ClickHouse. So one thing we do as well is give you a few different analytical views. This is a really quick one where if you're using traces, one common thing you're interested in is looking at a heat map of how long a specific event took. So this is like a heat map of how long a specific span took. You can highlight out a specific set of those, like, hey, like these spans look suspicious or take a little bit longer than I suspect. You could run basically a difference comparison between the different spans. So like, how do we compare these ones in this green box versus all the ones outside of the green box? And we kind of compare like which ones are the, what attributes are outliers here. So we kind of see like, hey, like what are some of the correlations of properties to duration of a given trace? So that's some of the stuff we do as well. And another thing I want to show is that, so we did traces and logs, and those are, pretty much, I think, the routine ways you want to use HyperDX for observability. But this really does work for every single table. So one example we'll do as well is we'll do the ClickHouse query log. Query logs is still kind of a log, but it's not, I don't think, people think of it from the traditional observability use case of your application logs. But we could do that as well. So we're going to pick event time, query kind. Let's just do query. And then I'll do one more thing, which is basically always search on the query column by default. So let's do that. Let's go switch back to results. And then here's our search. No, I need to run it. And here's our search. So this is running on the query log. The query log is usually a pretty verbose log. So it's kind of nice. We're able to do things like, hey, like I want to go find all my select queries. So maybe I can do query kind select here. Great. So find all my select queries. One thing I often do is maybe I'm actually looking at the profile events. So let's go find, no, this is probably a query start. Let's do, if I can go find one with profile events. That'd be really, okay, well, I'll go find something else in this case. Maybe I'm looking for something else, like maybe, hey, I'm looking by query hash for some reason. You can always, easily add a column from here as well, add it to the table. You kind of see, the query hash here. So if maybe you're looking up for a specific query hash by I for some reason, you can always do that here as well. And then I think the last couple things I want to touch upon really quickly is also charting. So of course, In fact, let's just go to dashboarding directly. Because, we can do searches. ClickHouse is also great for building charts as well. So we can make it really easy to, build together dashboards off of the same exact kind of experience I had before, where it's like, hey, find me the logs that contain user logs, for example. You can go create these kind of things. Of course, you can do, oh, that's an interesting one. But you can also do things like where you can do aggregations on things as well. So like, hey, like for example, I want to do an aggregation on the duration column for the 95th percentile. I can do that as well. I'll probably need to do some SQL to clean up this formatting, but you kind of get the idea of what you can build with the dashboards here as well. And I know I'm short on time, so I'll just quickly cover the last part. It also comes with a built-in ClickHouse dashboard. This is very greatly inspired by the existing ClickHouse dashboard that's available on any ClickHouse instance today. We figured, hey, we have a lot of great charts and searching and table capabilities. We can, help build one as well. Help users kind of, be able to look into slow queries, slow query patterns, inserts, part counts, stuff like that. Basically, just having you, giving you another dashboard to keep an eye on kind of how your ClickHouse instance is behaving. So that's pretty much it for the demo part. You can try this out today at play.hyperdx.io if you're interested. This ran completely locally to the browser. So none of this was hitting a server. This was all hitting directly to a ClickHouse instance. So if you have any local ClickHouse instance you want to try out, you can connect to it directly from browser from this domain. This is an early beta version, so that's where there's still some edge cases here. But ahead of the GA, we'll be working on adding alerts, metrics, JSON type support, and more features as well. Awesome.
I really like this UI for multiple reasons. One reason, because it feels really fast. It feels really natural for ClickHouse. And also because it is just a single HTML page, like a self-contained page with everything. And yes, you can replace Datadog with just a single HTML page.
Yeah, that was one of the questions, but I guess Alexi's already done it.
Okay, so what about integrations? For Tableau, the official ClickHouse driver is now available on Tableau Exchange. And for Power BI, we also have the official data source. In ClickHouse Cloud, now you can configure connection to a Postgres instance and continuously replicate tables from Postgres with what is named CDC, Change Data Capture. This feature is starting from yesterday. It is in preview, and you can participate in the preview. And there are a lot of improvements for dbt, Spark, Metabase, and usual suspects like connectors for Java, Python, and JavaScript. What else? Now ClickHouse has an official Docker image. The difference is, until recently, you used the Docker image from ClickHouse, like ClickHouse/ClickHouse server. And now you just type ClickHouse simply, because it is officially certified by Docker and curated. It belongs to a curated set of open source images. And a small update for CHDB, embedded ClickHouse library for Python and other programming languages. In the new release, CHDB 2.2, that will be published either today or tomorrow, the query latency and performance is optimized 1.76 times. And it is quite a big achievement. It just slashed most of the latency, like parasitical latency from Python. And now you get a pure ClickHouse performance. If you did not know, CHDB is a library available as a Python modular. And with this library, you can process data frames, remote datasets, local datasets, in-memory datasets, on-disk tables, just from Python, with the full power of ClickHouse engine. And we will have a lot of meetups starting from Paris that will start in 1 minute. So hurry up, you still have a chance to be on this meetup. And there will be AWS reInvent, a conference in Las Vegas for the next week. And we will host a house party on this event. And the house party will be with some musical artists. And probably you still have a chance to win a ticket. You just have to fill this form. But this chance is probably very low because we have only a small number of places. Okay, and if you want to read about SQL-based observability or how we made Postgres replication into ClickHouse, or how ClickHouse is used for AI, for security, for observability, go to our blog and you will find a lot of interesting stuff. And now 1 minute for your questions.
We have a statement which is, please come to India, which is then +1. Not sure if they mean ClickHouse or you in particular.
Yeah, I hope next year we will have a meetup in India. Previous year we already did in Bengaluru, if I recall correctly. And I think we should cover multiple cities, including Bengaluru, Delhi, and Hyderabad. And what other cities, please tell me in the comments, and I hope I will have a chance to visit.
Bulgaria, next one suggested.
Yeah, we should. We should make it.
A question we got on YouTube is, do you know what's the status of the new Kafka engine that uses ClickHouse Keeper for offsets becoming production ready?
It is currently available for evaluation under experimental status, and we are looking for your feedback. Currently, it is not actively developed. We're just waiting for this feedback to address your thoughts and to finish it.
And then there was another question about, I know ClickHouse is better than Lakehouse. We already learned that, but is there going to be write support for Lakehouses and then read? I think somebody asked reading catalogs, maybe was the second part of the question.
The answer is yes and yes. This is in the plans for year 2025. I will publish these plans in a month, so you will see it in the roadmap. And it will be catalogs first for reading and writing next.
And then another question on an experimental, what's the production readiness status of JSON, the JSON type?
It is currently experimental. It has a chance to become better in this current version, 24.11, but it is currently still uncertain. We have about 1 day before publishing this release, and my colleague Pavel, who is the developer of JSON data type, he has a chance to promote it to beta in the nearest hours. If not, it will be a gift in the version 24.12. After it will be beta, it will be generally useful, but still not recommended for production. And then 1 or 2 releases, and we will promote it to production, depending on the amount of edge cases, amount of possible bugs that we will find.
Cool. Anyway, I guess we're running a little bit over, so maybe we'll wrap up there. So thanks Alexi, thanks Mike for the demo. Everybody go and try out HyperDX and let Mike know your feedback and tell him how much better than Datadog it is, and then he'll be very happy.
Yeah, it will be definitely faster than Datadog.
And I think we are doing the 24.12 on the 19th of December. So it's just a Christmas special one.
Yeah, and it is very soon.
Yeah, I know. The year starts to go by quickly once you get this late into it. Anyway, cool. Thanks all for joining us on YouTube and on Zoom. We'll see you in a